Okay, so as a summary, I hope I managed to convince you that this data flow runtime system is easy to program. So you don't really need to do anything other than that, defining your basic computational task and giving the graph for that task. And our experiments show that even if you have fast processing units like GPUs, you shouldn't neglect your CPU because it's sitting there and you can use it and you can get performance out of that, and that actually can give up to 2 or 3 times performance. Okay, so one thing that people usually ignore is they focus one part of the computation and say how much I improved that part of computation. Okay, for a real application, end-to-end execution time matters. So you really need to do analysis for end-to-end performance analysis. Again, so large-scale data is a buzzword, but everyone talks about how they process larger data. But really, one need to look at to end-to-end performance. It's not just, you shouldn't be just worried about the size and how big data they processed. What was really feasible on that system and how fast they really did that performance. At the end, you may say, well, I mean, you have a really nice runtime system, but I can do everything you have done using MPI, which is a well-known programming, message programming system. And on the node, I can use, let's say, OpenMP using for multiple cores. And if I have an accelerator, I can use OpenACC, CUDA, whatever. And I can get this performance for my particular application. And my answer is, of course you can. This is how we implement the runtime system, right? So we didn't do magic. We actually use all of those. But the question is, do you really want to redo all of this for every single application? Or do you rather use a runtime system which is really optimized and you don't really need to worry about all of those things. You only worry about what is my computation and what's my computation graph. Okay? So basically, that sums it up. And of course, I haven't done this work myself. These are, I hope, close to complete list of the collaborators involved in multiple of these works. I listed people when they were, when we carried out the work, Joel, TASSA, who, when they were here, and Metin, of course, one of the collaborator in image analysis applications, and a couple of other collaborators all over the world. That's basically it.